Okay, so what I was missing is this. The internal unknowns, if you really want to have them, it's when you cut, after you know all the reactions, which are 12, right? And then you cut the free body diagram like this. When you cut the free body diagram like this, you have 3 reactions. You can solve for 3 more. So you have 3 internal unknowns here. And then you cut another free body diagram here. You know all the reactions you have. You can solve 3 more, but you have 3 more unknowns. And likewise here 3. So internal unknowns are actually 9. So plus 12, in fact, the total of unknowns is 21. We have 3 equilibrium equations. We have 14 hinges. So that is left with 4 unknowns, 4 more, right? Which are the shear. So the 4 unknowns are these 4 shear, which are solved by using the Porter method. So that completes all the 21 unknowns. Okay, so that is clear. Okay, so let's move on. Now, okay, it's gonna get hairy a little bit. Now we know this. Remember that we cut this free body diagram here at the hinges. So now we can focus on, I don't have the member name at all, so it's going to be pretty difficult to refer to something. Let's give it some name, okay? Maybe A. Now let's say use some more distinctive color. Which color do you like? No answer. So I'm just gonna go
Purple.
Purple. Very well. A, B, C, D, like that. E, F, G, H, I, J, K, and L. Okay. So now we're going to take a look at member IE. When you look at member IE, well, now what do we know? This is the free body diagram of IE. You know that this is from this. You know that this is 20/6, correct? From here. And since this is the free body diagram, let's try to have everything. Okay, that's a hinge. Okay, and what do we know? By using sigma fx, of course, you now know that this has to be 20/6. Look like a 6. Okay, concentrate. And now this is 20/6. We also know that by taking the moment that is hinged, say the moment will be equal to 20/6. We take the moment at the hinge, right? Now multiply by the height here, which is 2 meters. You see, this is 2 meters because the length of this column is 4. So the moment here is 40/6. What's the unit? Kilonewton meter. And when you take the the moment here, your shear is going to the left, so your moment must be in this direction. And on top, the shear goes to the right, so the moment must go to the left to balance. Okay. Are we still doing okay, right? where should I go next? I have so many things on this one. Let me try to find the redo. I have this. Use this one. Okay. Now you can repeat the same thing with other columns on this floor. Okay. Now let's move on to the next column, which is how do you call that? JF. JF, KG, even Garnet, right? And LH. With the same method, you will achieve the same thing. Okay, JF. Please tell me if you can't catch up. Okay, I don't know if you should stop and listen or you should try to write down. I will try to give you some time. Okay, so I will draw these 3 columns.
Can I have a question now?
Yes, yes, please.
Yeah, okay. You mentioned for the first part that you cut on the hinge, right?
Yes, yes.
Yeah, and this one will be
this is the member
here. Yeah.
See, this is the member now because you see that's a hinge in the middle. So that's the entire member. I call that a member, i.e. Okay.
Yeah, but this one will draw in from the hinge, right? It's on the middle of the member, but why is one will be the how to say it will be at the.
You mean why how I can obtain the moment?
Oh no. I just wonder for the location of the bed shear for IE because you draw is with it bed shears.
Well,
right?
Yes, it's true. Oh, I see your point now because we cut the free body diagram at the hinge and we achieved this, right?
Yeah.
And in fact, I can do the same by drawing just this free body diagram as well. If we are going to be absolutely correct, because say that's going to be the shear somewhere at the hinge. It's pretty tricky to draw because that's going to be the shear at that location. And if it's a shear at the hinge, you're going to have to start by drawing the free body diagram of the hinge itself. Okay, so it's something like yeah, let's do it that way. So if it's a hinge, to complete this free body diagram, it's going to be if it goes to the left, then this is this. Okay, and then on top is this, and that. Okay.
Yeah, I see.
Mm-hmm.
Thank you.
Let's remove this because I think it's not going to help. It's going to cause confusion instead. Okay. All right. So we can now move on to other columns, knowing that the hinges are in the middle as well. And now we are just going to do the same thing. We're going to apply the shear that we already know from this free body diagram. So you see, it's not difficult, but you have to have a strong focus. So this is 20/3. That is 20/6. That is 20/. Ooh, you see that? See what I say? That's over 3, right? And then that's over 6. So I try to use the color orange here to remind you that we have these numbers from the free body diagram here. Okay. Now from this, we can proceed by using sigma fx equal to 0. That will give you this, that, and then that. So from now we know this, we can calculate the moment. Okay, and here let's call it for clarification, IE. Okay. So now MJF is going to be that load, 20/3 multiplied by, because we can calculate the moment by taking the moment at the hinge, right? That's where moment is 0. So remember that the moment arm is always half the length of the column. And this shear goes left, so the moment must go right. This is 40/3. And this one goes right, so this one goes left. So you see the direction of the moment is pretty much similar to what we have done before. Okay, are you still with me? If you want me to stop so that you can catch up, please let me know right away, okay? When you get lost, it's just very hard to come back to, because when you look again, you see a lot of numbers all over the place. You don't know which one comes before which. Okay, so try to stop me, and I'm trying to go as slowly as possible. And I honestly do not know if you should stop and listen, or you just should try to catch up by writing. So I'm going to try to be very slow here. And similarly, the moment here is 40/3. Here is 40/3. Here was 40/6. And here is 40/6. Notice that up to this point, we only have the shear and the moment in the column. We haven't got the axial force in the column just yet. Okay, now let's say this is the second stage. We've come this far. Are you with me now? You want to take a moment to catch up with the numbers and so, or make some notes? See, that's why free body diagram and equilibrium are the two most important things in civil engineering. If you got this from your days of statics, this is like playing some games, really. Okay. If you don't have anything to say, I'm just going to move on. So now we are looking at J, right? Okay, joint J. At joint J, from this, you will see that if I am going to draw the free body diagram, so try to look at this free body diagram and try to look at this at the same time, what I'm about to write. So now we have the joint J, and we have the external force here, 20 kilonewton. Now you have the moment, which is counterclockwise. So this guy should be clockwise. That's 40/6. Okay. And you have the shear going to the right. So you must have the shear here going to the left. That's a free body diagram according to the forces you have from the column and the external force. Okay. From this, I am trying to use the this is orange already. We already used purple for the name. So let's use say this one, see if you can see it. Okay, meaning now you know that this moment is, oops, sorry. This moment must be equal and opposite. Okay. And this shear again must be equal and opposite, and it becomes the axial force in the beam. Okay. Now we can move on to the beam element itself. This guy is what member that is? This is IJ, right? Okay. We also have a hinge here. And now we have the moment. Now this moment is counterclockwise, so this becomes clockwise. Oh, I hate this. Okay. And it is 20. Let's use the same number so that no confusion. 40/6 kilonewton meter. Okay. Now, from this, you can calculate by taking the moment at the hinge. This moment is sort of rotating up, so you need the downward shear here. And this shear, you know, multiply by the moment arm. Remember, your member IJ is 8 meters long. So this moment arm is 4 meters. So this shear multiplied by 4 must be equal to 40/6. See, it's basic equilibrium, nothing fancy about it at all. So this becomes 10/6. Are you still with me?
Yeah, but I have a question for
Yeah.
J. Okay. As you mentioned, we consider from J. The moment from J that you bring is from JF member, right?
Yeah.
It should be 40 divided by 3, right? And I would like to know 40 over
40/6. 40 divided by 6.
Yeah, it is from.
It's from member IE.
Oh, you use from IE, right?
Is the name of the joint correct? Yeah, right. Thank you.
Oh.
Yeah, it's I. It should be sorry. Yeah, that's what is messed up is the name, not the calculation. It's I. It's joint I. Okay, not J. You can't begin in the middle because joint J has 3 members coming in. This is joint I. Sorry.
Yeah. I understood in the first time. Okay. Thank you.
Thank you. Thank you. That means you are coming along nicely. Your focus is here. So, okay. Now we've got this. And then your sigma Fy. I'm running out of ideas to be consistent with the colors. Okay. Now sigma Fy will tell you that if you have this downward, this better be upward and 10/6, right? Better be that. So meaning this is equal and opposite by the sigma Fy equal to 0. So no brainer that the moment here would be 40/6, but in the opposite direction. Okay, so that's IJ. And now it's going to get more hairy, but it's not, you know, different from what we've done in terms of equilibrium, because the next coming up is joint J, which is essentially something like this. You see, I'm not dealing with the axial, I'm sorry, the horizontal forces yet. Okay, we can do it later. Now we got 40 over 6 here, so we know that this is this. Okay, from member IJ. Let's call it, this is joint J. You got 40 over 6 from member IJ. And then now here, you got this from column JF. This guy is going this counterclockwise, so this is clockwise. 40 over 3. You can make note yourself how these guys come from. I don't know. I'm going to try to do this, okay, and see if you like it. If you don't like it, I'm going to remove it, okay? This from this. And this is from this. Is it confusing or is it okay to have them?
Yeah, it's okay.
It is. What about others?
It's okay.
Okay, good. So, you see that this is because the structure itself is symmetric, okay, and we are just analyzing the internal forces due to the lateral load. It should make sense to you that this moment, because this is 40 over 6, this guy is 40 over 6 counterclockwise, this is 40 over 3 clockwise, so this should be 40 over, oops, direction is wrong, 40 over 6 counterclockwise. So you see, it's going to give you the end moment that is equal on another beam adjacent to this joint, right? And let's focus on the moment first. Now you have the member. Leave colors really. This is going to be member JK. Okay, so now this moment is counterclockwise, so you have that 40 over 6. See how similar this is, 40 over 6 with that. Okay, and actually you can get ahead of yourself a little bit, because if you know the end moment here is 40 over 6, you can guess on the opposite end must be equal and opposite, right? But be careful, because member JK has different length from member IJ, but you better be careful. That's Hinge. And you now, this is 2 meters rather, not 4. So now your shear here is going to be V multiplied by 2 is equal to 40 over 6.
Excuse me.
Yeah.
The length of JK isn't 6.5 meters will be 3, right?
Oh, really? Oh, yeah, you're right. You're right. Thank you. Didn't look. Use the instinct, which is wrong. Okay, that's why the number looks strange. Okay, yeah, you're right. So we have say 20 over 9. And yeah, now you know you can carry on and achieve the same thing here. Okay, 20 over 9. And the moment here should be 40 over 6. Okay, you see, it's not difficult at all. You just need to concentrate. Okay, and I think similarly, you can do the same with member What's that? What's the name? KL. Okay. Woo. Okay. And maybe it's not a bad idea to try to draw the joint first. Okay, so similarly, you have 40/6 from member JK, which is the beam, and then you have 40/3 from this guy, right? So it is going to be the moment in this direction. So similarly, you have another 40/6 here, which, you know, coming over here as 40/6. And now this is going to be similar to IJ, correct? So you look at IJ, now it's the same length and same moment. So without further ado, we can go ahead and say, okay, here is 10/6, 10/6, and here is 40/6. And if you want to be so complete, now it should end with another equilibrium for the joint, which miraculously, now this is 40/6, so here is 40/6. And if you go back and look at this, it's 40/6 counterclockwise, so you have the clockwise one, and voila, your joint is under perfect equilibrium. So you like to take a breather, maybe? Okay. So now the second step, you sort of know that from the shear in the column and the moment in the column, you can now calculate the shear in the beam. Okay. And I can draw this again, but let's separate the shear out of here so that you can see better. So this is again joint I. Yeah, right. From joint I, you look at member IJ, you know that, let me draw all the joints. Ooh, that look good. Now, this is the time where I think, you know, a board, the whiteboard might help better. IJKL, right? So now from member IJ, you have this downward shear, right? So this better be upward, 10/6. This is upward 10/6. So at joint J, this is going to be downward 10/6. Now we move on to JK. It's down 29. So this better be up 20/9. And K, likewise, you're going to have 20/9 down. And 10/6 is up instead. And the last one, it's down. Okay, so from this now, you will have the forces acting on your columns. Okay. And where are we now? Okay, I need to take a breather myself. Okay, now. We can come back and take care of the axial force later because it's not that difficult. So let's try to move on to the joints in the say second floor. Can I call that second floor? No. Anyway, it's now we're gonna focus here. E, F, G, H. Okay. So now let's say here we have this. E. Now from the first column, you have this, right? The moment and the shear. So here is 20/6 and 40. Okay. 40 is the external force. So now you know this has to be equal to how much? 40, that's 20/6 is 10/3. So if you make that 3, so it's 120/3, right? Minus 10/, really? Am I correct? Sounds weird. Hang on. I thought I figured this. Okay, and hang on a minute. And we also have the moment. Okay, we have this as well. Maybe I should start from the fact that we have the base shear equal to 10. So from here, we should draw the free body diagram of the column as well, correct? And we have the hinge, don't forget that. And we have the base shear, so we know that this is 10 already. So we sort of know that oops, this is also 10. Okay, and that means this is 10. And then we're going to come back and take care of this later. Okay, so let's remove that first. Okay, but we know that, and you can choose to complete all the columns just like before, which we have done, right? Like this. So yeah, let's go ahead and do that because it's pretty straightforward. This and then that. Okay, just like before. Let's add some hinge here. And you know it's 20, right? And this is 10. So we can use the sigma fx equal to 0. Know that this is 20. That is 20. That is 20. And you can also go ahead and calculate the moment. This shear down here, this is 10. So you know that the moment is going to be in this direction. And the height here is how much again? Oh, 6 meters. So that is 3. So now we know the moment is equal to 10 multiplied by 3, right? Which is 30. And you sort of know that this is also 30. And right here, the moment is 20 multiplied by 3, so it's 60. Here is 60. Okay. So with that, now we can sort of try to go to the B. Okay. Remember that it's nothing unusual at all. Just you have to be very, very concentrate and pretty good at bookkeeping.
Why the last as the fall is not the same one?
Oh, you mean this one, right?
And then 20.
I forgot. That's why. Okay. Okay. That's why. All right. So here, without further ado, it's 60. Now you can start filling in the blank. 60, 30, and 30. Okay. Now the point is we need to get to the beam, and from here, you know this is 30, so that is 30. Okay, and we also have the moment from the column above, which is this one, the green one. It's 40/6 or 20/3. Oops, what's the direction? It's counterclockwise. So you have the clockwise one here. So from that, you can now obtain this moment, right? Which is equal to 30 plus 40/6 or 20/3. So it becomes 110/3. That's the moment in the opposite direction. Okay. So now you have this moment. It means that you can, maybe is it better for me to move the joint downward so that, you know, we can use this to calculate the beam element. Is it better to do this? Maybe. So now from this, you know the end moment of this, oops, of this member, which is the member EF now. Okay? So now you know that this moment is 110/3. Okay, and remember we have hinge here. So you know this goes up, so this one comes down, and then yeah, so and so, and maybe what should we you know, right now you can see that you can go any way you wish. You can try to complete joint the F, maybe to get the moment on the on your beam, or you can just go ahead and calculate the shear here. You don't have to follow every step I do. It just, you know, what you prefer, really. So maybe you have this here, so the shear here is you know, phi. What color did I use? That's just pink. Okay. So here we have V. It's a first beam, so the length is 4 multiplied by 4. It's going to be equal to the moment, which is 110/3. Okay. So now you have this divided by 4, so it becomes 55/6. Okay. And And from that, you can sort of use the sigma Fy to get the equal and opposite shear. And if you know that this is 55/6, meaning the moment is going to be similar, but in the opposite direction. Okay. So now you're going to come across the joint where it gets slightly more complicated, because now you have everything, you know, because it's a joint in the middle floor. Okay. So you now have this. And I think I lost a way to, I'm lost to try to find a way to help you track this. If this is 110/3, that better be 110/3. Oops. Directly coming from here. Okay. And then you have this moment coming in from this column. That's 60, right? I can instead write like this. So from what column? From FB. But you have a column above, which is a column JF. But that's JF, counterclockwise moment. And so it comes down here as the clockwise moment. How much? Okay, it's a 40/3, right? Am I correct? Yeah, 40/3 from JF. Okay, so now it becomes a simple arithmetics, because from this you now can have this. Oops. With simple arithmetics, right? And that's gonna be where the heck is it? I don't have the number. I believe it's 110/3 as well. Okay. So now you can use this to calculate the next beam. Here is the guy with there. And now you have the shear. I'm sorry, the moment coming in from 110/3 here. So this is this, right? Okay, and that's the same. And now the shear here is going to be V. The height in the length in the middle is different, so that's multiplied by 3 is equal to that. Okay, and so and so. And do I have the axial force here? Let's try to keep track of this a little bit. And the axial force is just, again, a simple arithmetics, you know. I don't know if I should try to write them down now, or it's going to confuse you. What do you want? Let me ask you this. What do you want me to do? Now you have, if you go back now, this joint, the axial force here is missing. The axial force is missing, which we can, this is the top column. So you just take this, add them here, and then you can go on and add more this axial force to the joint. Okay, I can do it for you, but I'm afraid that if I write more in the joint now, it's just going to be a lot of numbers. So I don't know what you want. You want to take a breather now? Maybe? Anyone talk to me?
Can you copy for this one and delete other reaction and just put only the axial?
The axial?
Yeah.
Okay, let's try to do that. So maybe it's appropriate to do it here. We have space. Okay. You don't say anything. So let's try it here. You see, it's kind of a nightmare myself, you know, trying to create this. So we have the external force 20, right? And now we have the shear coming in from the column. Let's try to use orange. Seems like a good idea. The shear from the column here it's pretty much the same, right? It's 20 over 6 and then 20 over 3. So here is 20 over 6. Here is 20 over 3. Wow, when you draw it like this, actually, it's pretty easy. Because, you know, in the end, these four shear, you know, they add up and equal to 20, right? So you keep deducting this. In the end, it's going to come down to 0, correct? So, this is going to be 20 minus 20 over 6. So let me find the number. That's going to be 100 over 6. Right? So that's this is 120 over 6 minus 20. So that means this is another 100 over 6 coming from the pink one, and then in turn you minus that with another 40 over 6, so it becomes 60 over 6 or 10. This is then 10 minus another 20 over 3. That's 30 over 3. That becomes 10 over 3. And wow, that's 10 over 3, or oops, sorry, should be orange, right? Ah, so that's 10 over 3. And voila, you have it. Now don't forget to bring this. Oops, let me do that. Bring this back to your beam as well to complete the free body diagram of members IJ, JK, and KL. Okay. Now you have IJ, so you're gonna have the axial force here and here and here and here and here and here. Okay. So you see, after we figure out how to solve the shear, it's just pretty simple. But you know, it's like trying to maneuver over the minefields. Simple, just taking a walk, right? But don't step on any minefield. So it's the same, and it's getting a little bit more for the second floor, but it's just, you know, same process. And we can go on and on. Okay. So if you want me to complete this, I will. But I think it's time for another break. You get the idea. Right here, we are only at the second beam, so we have one more left. I don't think it's difficult to try to finish that. So if you want, we can do so, and hoping that we can track everything correctly, because it's just so many numbers. Okay, and well, I guess any question then? Are you still following me?
Yes, yes.
What about others?
เคครับ
Actually, it's a lot of fun, you know, because once you crack the shear, everything is determinate. You just have to keep plugging in, okay? Now, I don't even have to show you this because simply it just trying to solve the members and the joints beginning where you have the least unknown, just like taking the method of joint in the truss. But this is a the flexural members, not the true force member. That's all. So it has more, it has moment. Okay. And you can do the same to obtain the here, it's the axial here. You can do the same to obtain the axial for the joint, the second floor. And now we have cracked the second beam. The last beam is just another joint like this, which, you know, it's a similar, correct? Because the moment from the top column, the moment from the bottom columns, they are the same. And now we have 103, so it's the same, okay? Anyway, if you don't have any question, let's take a break.